All right, let's go. Define variables. So at the concession stand, football game, they sell pop cans and hot dogs, right? So that should, usually that's how they set the stage, right? So X would be number of cans, Y would be the number of hot dogs, right? And be careful, sometimes it's hours worked or grams of something. So most of the time it's number of, which is discrete, right? Discrete data we're talking about. That's our implicit constraint. So I'll make that whole thing just worth 1 mark, okay? So the stand owner would like to sell at least, right? Sell at least this much worth of goods. So we're going to make sure that appears here. We need to make sure that our variables will have a dollar amount in front of them. That's where they come in. Okay, so $1.25 for a can and $1.50 for a hot dog. That has to be at least 780, right? So it doesn't matter how many you sell of each, as long as you have this side be greater than 780, right? That's what that is saying. So I would give you a mark for that. A mark for setting it up, right? And then a mark for that inequality. And this one I'm curious to see what happened here. The stand has a capacity to hold 175 cans and 450 hot dogs. That word capacity, I don't know if you've come across it in the homework already, but capacity is kind of indicating that can hold up to, right? A bus has a capacity of maybe 50, right? Or whatever. That means that it can hold up to, right? Holds up to 175 cans, holds up to 450 hot dogs. That is actually, if we're just talking about the cans, right? The number of cans has to be less than or equal to 175. That would be 1 mark. And the number of hot dogs has to be less than or equal to 450. It's actually specifically speaking to each variable separately. It doesn't say can hold, you know, if you were to add these up, you'd be at what, 625, right? X plus y is less than or equal to 625. Don't do that because it's not saying it. It's specifically to cans, it's specifically to hot dogs, right? So you need to have 2 separate ones there. So that's where the 4 comes out of. So put a mark down. If you get, you know, the setup and 1 of them, then it's 2 out of 4. You have setup and 2 of them right, 3 out of 4, and then 4 out of 4 if you get them all. Just don't be scared to make a mistake, right? Right now, the stakes are very low, right? Kyle has 2 jobs. Job A pays $14 an hour. Job B pays $18.91 an hour. Kyle would like to know possible combinations of hours he would work at each job in order to maximize his income. I can tell you already that you're going to see a lot of these questions later on, but I first wanted you to like see them and just write the inequality, right? So I will let X be. Some of you might have just put job A, right? But it's actually hours at job A, and Y is hours at job B. Okay, it's important that you can do job A and then brackets hours. That's fine too. And then X and Y, since we're talking time, has to be greater than or equal to 0. Okay. And job A needs him to work at least 20 hours per week, right? 20 hours per week. Oh, sorry, I missed this one, right? He would like to earn at least $645 in 1 week. So that's when you take the dollar amounts, like $14.50 for every hour at that job, $18.91 for every hour at this job, and that combination has to be greater than or equal to 645. So that'll be a mark for that. Job A needs him to work at least 20 hours per week. So job A would be X, right? So since it represents the number of hours, that has to be greater than or equal to 20. That's a mark. Job B pays more, but only allows no more than 25 hours per week. Right? So job B is less than or equal to 25, no more. That's another way of saying less than. So that's another mark there. Kyle can only afford to work up to 47 hours per week between the two jobs. So hours at the first job and hours at the second job has to be less than or equal to 47. So there was a bit, right? Lots going on. You have to kind of decipher what's going on here. But the dollar amount should only show up when there's a dollar amount on the other side, right? And so out of 5, right? So setup is 1, and then 2, 3, 4, 5. So 1 mark for each of the inequality. There's 4 inequalities in this scenario, right? So see how you did there. Determine the inequality of the graph below. Assume regular shading. Read carefully, right? So, but we're told that this is the solution region. That's y is less than or equal to. Boom. This is a solid line. And there's no hint here, so let's see. I'm going to start at the y-intercept. Is it here? I'm going to keep trying. I'm going to just check here. 1, 2, 3, 4, right? To get down to that. And then 1, 2, 3, 4, 5. So it's 4 and 5. I'm going to do it one more time. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yes, that's it. So it's negative 4 over 5x plus 8, right? This is 8. 2 marks for that. You know how that goes, right? And so we are at 11 for this one. 11. 11. Is that, how do you say 11 in French? Once? Once in Spanish. All right. All right. Take out. Okay, so if you go to page 52 in the first booklet, so today and tomorrow, most likely still this first booklet, and then we're going to switch over to the second booklet. I just thought I'd give you a bit of a hint or some tools here. So I grouped them up. There could be more, guys. I might add to this later on. Page 52. It's basically the last page of this booklet. If you want to write this down, it's up to you, right? But if you see words such as up to, at most, maximum of, a capacity of this, holds, or no more than, we're looking at the symbol will look like this, right? You got to watch out for there. I think there's one question in the booklet I gave you where you have to, it's only going to be less than or greater than. It actually does say very specifically. But overall, you don't have to worry about that. We don't have dashed lines and word problems, really. It would make it too complicated. All right, because technically the point of intersection then would not be a solution to the system, and it's just, and it makes a very slight difference to have a dashed versus solid. You just have to move a little bit in. If you see at least a minimum of or no less than, if you see that, then the inequality would look like that, would open to the right. I don't know, your teachers probably used all kinds of stuff, right? Pac-Man or alligators or whatever. I just tell my students to read it from left to right. Okay? Because this side is less than that side. And if you look at it this way, this side is greater than that side. Once you have this written down, we're going to go back a few pages and continue with our notes. Okay, so hope you got these. So we're going to go back. I'm going to take you to I think I'm going to go straight to 46. I assigned these ones for homework. So on page 46, if you didn't do the homework, then it's probably a good idea to write down those inequalities real quick. I wrote them down right next to the bullets, but then I kind of started all over. I set up my question here, and then I wrote them down all three here. This is my system that results from those restrictions. So write them down if you don't have them. I will go over them briefly, but yeah. Are you going, Brady? Anybody else? Maybe I should sing. I'll just leave. All right. Thank you. As I was saying, anyways, so yeah, right. We come up with the intercepts. They're very easy to do. You're gonna get one of these almost every time, almost. So that one is the easiest one. So if this had been 20, it would have been 20, 0, 0, 20, right? Rewriting it is very easy. You just bring the x over. No need to divide or anything. So you just get that, okay? These ones are a bit trickier. So that one I'm going to call this IQ2. I'm going to call this IQ3. And this is IQ4. That way I don't have to keep rewriting it, okay? So IQ2, I'm going to work with it here. So make sure you write this down. Later on, you can look at it. And I have a feeling that the space will be extremely scarce here, so you might have to do something about that. So I'm just going to go 7,500 x is equal to 225,000. I'm going to divide both sides by 7,500. X is equal to that's 30. Not always will you get a nice round number, but if you do, that's nice, right? And then it's 15,000. Y is equal to 225,000. Divide both sides by 15,000. Y is equal to 15. 15, 0, sorry. 15, 0 is the answer, so 0, 15 is what we're after. Box that in. So I'll tell you what my goal is. My goal is to graph it in this corner here. So that's why I'm trying to keep my work on the left side. Rewriting this one. 15,000 y is less than or equal to negative 7,500 x plus 225,000. And I will show you a little trick here. You can cut all the trailing zeros because you can technically divide this whole inequality by what? You can divide it by 1,000 because all of them have, oh no, sorry, not 1,000, 100, right? Because so you can get rid of 2 zeros. I'm going to do that. 2 zeros here, 2 zeros gone there, and 2 zeros gone there. It makes it a little bit more manageable. So that ends up with 150y. And by the way, if you miss that, it's not going to affect you, right? You're going to get the same answers. It's just reducing it a little bit. Divide everything by 150. Y is less than or equal to. Your eyes are probably hurting, so let me zoom in there. That's a negative 1/2, right? Because 75 and 150, right? That works out. Plus, I'm expecting this to be 15. Solid line, true region is below because it's less than. We will shade above. So I'll box this in as well. I am telling you that this is one of the crazier examples you're going to see. This is kind of like as hard as it gets. So the example is tedious. Usually it's not this much work, right? There's less going on here. So let's do IQ3 here, right next door. That's the 6xy, right? So I'm going to go x-intercept, y-intercept. I will usually be pretty good at giving you space to fit everything in. So this is 6x is equal to 115. Divide everything by 6. That's 19.16 or 17, right? So that's not a pretty number, but that's okay. It's just for graphing purposes. So 19.170. And then next door here, it's 7y is equal to 115. Divide everything by 7. That's 16.43. 16.43. Box that in. Let's rewrite it. If your head is hurting a little bit, just follow me. Okay, it's gonna be all right later on. And watch what I do here. I leave it like that because this goes into the calculator. So I just leave it divided by 7. I don't turn it into 16.43. Solid, true is below. And I will tell you, you might forget, but we don't really divide by negatives in when it comes to word problems. So you don't really have that issue. So students tend to forget. And last but not least, I'm going to actually try to do this one right there, the IQ4. I don't know where you have it. Remember that special case? Like this one, it's harder to graph, right? Because if you plug in 0, you're going to get 0, 0. Like this one goes through the origin. So you let x be, what would you like it to be? Pick something smart. I'm going to let x be 5. Then y is going to be 2 times 5, right? Y is 10. So you know that it's 0, 0. And I just found a point 510 on the boundary line. That's the special case. We can go right next to it and say this is a solid line. Where's the true region on this one? Arriba, right? Phew. This is pretty painful, Mr. Dirksen. Don't do this again. I'll try. The graph is going to, I'm going to try to fit it in right here. in 5 minutes. So we're going to stick to quadrant 1. And if you are, if you can't write this down, and you rather pay attention, that's fine. But for homework, you need to make this go onto your notes, right? And I can finish this video later. Okay, so this would be number of cars. No, sorry, number of vans. And this is your number of cars, just like before. And what you need to consider when you graph these, for your x scale, you need to look at the highest x-intercept, which I see right here is, I see a 30 there, I see a 19, and I see a 9 way up there. So 30 will do. So I'm going to go 10, 20, 30, and 40 just for good measure, right? Just make sure it's equally spaced out. And for the y, I'm looking at, there's a 0.15, 0.16, 0.9. So we're good. So I'm going to choose the same scale as here, 10, 20, 30, 40. Plot the first one, 30, 0, 0, 15. I strongly encourage you to draw your lines right away and label them. Okay? So this would be, where are you original? I need the original. 7,500x plus 15,000 y, and you might cross this one off by doing your other lines. That's fine, not a big deal. 0,990, I'm going to graph that right here. This is x plus y is less than, no, it's greater than or equal to 9. 1917 and 016 is right there. And the last one is 00 here. And then I had 510 going here. Have a great day, guys. We'll continue with this tomorrow. The only homework is, all right, I'm going to continue with this graph. So just make sure it's on in your notes, page 46. And here we go. My ruler. And I've graphed all 4 lines. I should have probably stretched it out a little bit in retrospect to make it to make the solution region a little bit more visible, but this will work regardless. So one line at a time. Okay, so I'm going to start with this one here. I have to shade above for that one, and so that would be this line right here. I'm going to shade above just lightly, not to cover up all the labels and stuff like that. That's all up there. That's all gone, right? It can't be the solution at all, including this little sliver here. Okay, and then we have our third line, just this one. We're also told to shade above, right? So we're going to shade above that line. So that kind of gets rid of this little sliver here. That's all gone. Okay. Everything above that line is false. All right. Then we have the very first line is 9009. That one is actually being shaded below. Okay, so we shade below that one. Like that. And this special case, so to speak, we're going to shade below that one. So we put our ruler right against that line, that boundary line. And so everything below that is gone. Okay. So our solution region is right in here. Okay, so I write that in there. That's my solution region. That little, any point from within that box, or that polygon, I should say, is going to be a possible solution to. So this is giving you, this section is giving you all possible solutions. So we just graphed, right? We graphed this and gave all possible solutions to that. State a possible solution. That's what E is saying here. So you could say, for example, you could actually use anything in here. You can state anything in here. So I'm going to go like 110, right? 110 would do the trick, producing one car and 10 vans, right, is a possible solution. And think about it, right? You are, this combination is true for all of them, for every single one of them, because it's in here, right? You're making at least twice as many vans as cars, right? At least. So this is actually way more than twice as much. It's 10 times as much, but it still remains true, right? And this is probably the most challenging part for this particular example, is finding the points of intersection. Okay, so I'm going to enter all of my equations and graph them at the same time. So that's why I rewrote it, right? So -1/2 x plus 15, and there's a -x plus 9. Then we had the 2x line as well, and the other one was the -6/7, right? So I'm not necessarily going in order, but that's all right. Plus 115 divided by 7. Watch how I enter that. I keep that to not have to round, okay? So then I'm going to use my window. I'm going to go all the way to, like, let's say 30 here, or a bit further on the x max. 32 perhaps. Y min, I'm going to go all the way up to maybe 40, right? And then I graph that. There is my graph, and it does look like it. If you put it side by side, there's a resemblance there. So we're interested in this box right here. So how many corner points are there? Well, there's going to be these two for sure. We're going to read them off the graph because we already know these points. We figured out the intercepts earlier. So what we need to find using our calculator is this one. And it's very hard to see, but it's actually, there's an intersection between the black and the, what is it, purple, right? And then there's also an intersection between the blue and the purple. So there's 1, 2, 3. 3 points of intersections there that we're going to figure out. So let's do the first two that we already know. And one of them is 0, 9. It's this one here. And the other one is 0, 16.43. And because this is discrete data, we're going to go 0, 16, right? Round it up or as you see fit, right? And then so let's figure out the other one. Second trace 5. And I'm going to figure out the intersection between the blue line, and I'm going to jump till get to the purple. Right now I'm on the purple line. See, the whole thing turned purple. I'm going to hit enter, enter. So that's 413 actually, exactly. Not too bad. 413. That's this point right here, right where those two, and then I'm going to figure out the other one, right, between the purple and the black, right? I'm going to figure that one out. So second trace 5. I'm going to jump to the black line, and now I'm on the purple immediately. So there we go. That's 5.75, 11.5. 5.75, 11.5. And we're going to round that, right, arrow. We're going to go 612. Okay, 612 like that. And I still need to figure out between the red and the black there. So I'm going to jump to the red, and then I'm on the black there as well. So enter, enter. So that's 3, 6. 3, 6. So I have 1, 2, 3, 4, 5 corner points surrounding that solution, right? So it's very important to get that right. Maybe I will take this. It's not so clear in this graph, but when we graphed it on our calculator, we had them there. And so most of the time, when I give you a graph, it's going to be a lot easier to see, right? But in this case, because we don't have a grid, right, it's harder to see that. So hope this helped. So make sure you review how to write inequalities, okay?